Hello my dear, this is Ujjwal Kumar Sen, and in this video tutorial I am going to share with you solidification time. Yeah, this is a topic of casting. You know that probably, that's why you have landed this page. And in this topic I am going to share with you a principle, principle, principle or rule, right? So this is about it. I mean, this is a principle, and this rule is a rule which is known as CHBO. This is a little bit difficult spelling because it's a name, Korinov's principle. This principle is known as Korinov's principle. Okay, I hope you got it right now. Okay, so according to this principle, what this principle basically states, I have to share with you. This principle states that solidification time is directly proportional to the shape of the casting volume divided by surface area its whole square. And we can also write this TS is equal to K volume by surface area whole square. This K is known as solidification factor. This K is known as solidification factor. One of the most important thing in this video I am going to share with you, that is, what is the unit of K? You need to know. So how you can able to find out its unit, just I am going to share with you. Probably you will forget in exam. So this is solidification time, right? That means in second, if you are talking about SI unit, second. K, leave it. Volume, meter cube. Surface area, meter square. This okay. So this one cancel, m would be remaining, so m square. Then K is equal to second per meter square. So what is the unit of K? Second per meter square. Remember this. Unit of K is second per meter square. I hope you got its unit, right? So now let's go for few shapes. Okay, shape like what type of shape we wanted to cast. Based on that we can find out solidification time. That means solidification time is also depend on the casting, I mean the shape of the cast. Okay, the shape which for which shape we wanted to cast. Okay, so let's go for it. First let's go for cube. I hope you can see. Yeah, for cube volume by surface area, it's cube, AQ surface area 6A square. So it's A by 6, right? Now second, let's go for cube. You know what is cube? Let me share with you first. Probably you forgot. Okay, I know you know. This is a cube, right? Whose length, breadth and height, all three are same. That is known as cube. Now let's go for a sphere. Okay, suppose that this is sphere and this is diameter and its half part is known as radius. So volume by surface area. So the volume of the sphere is 4 by 3 pi r cube. Its surface area is 4 pi r square. And after calculation what we get, pi get cancel, 4 get cancel, r. So r by 3, that means d by 6. This is for sphere. I'm just trying to share with you relation between volume by surface area of different shapes. That's why when will you get questions in the examination, it will become quite easier for you to solve the question right away. I mean to solve the question also in very less time. That's why I'm doing all this. Now let's go for cylinder. Okay, cylinder, this one is for cylinder, right? So in this cylinder, let's say its diameter is d and height of the cylinder is h. So volume by surface area, volume cylinder, what is the volume of cylinder? Pi by 4 into d square into h. Okay, now surface area 2 pi by 4 into d square plus pi into d into h. This is the formula. Now, most important thing, if we are considering a cylinder whose height is equal to diameter, then the case, what would be the case for this? If height is equal to diameter, then what would be the value of volume by surface area ratio? That is interesting, right? So let's just put the value and get the answer. So pi by 4 d square into d divided by 2 into pi by 4 into d square pi d square, because h is equal to d. So what we got here, pi by 4 into dq, it's 2d common to pi d square plus 2 pi d square. What we got here, therefore pi by 4 into d to the power cube 2 by 3 pi d square. Pi get cancelled, 2 by 2, so the remaining would be dq by 6. Now, most important thing we can notice here, it's not dq basically, dq by 6d square, so d by 6 would be remaining. So now, let me write first in figure. D by 6 we are getting for cylinder if h is equal to d and its volume by surface area ratio is d by 6. Now look at the volume by surface area ratio for a sphere. That means volume by surface area ratio for a sphere and cylinder for both it's same. For both it's same. So don't need to be confused in it because it's really simple. So this concept, actually based on this concept, in GATE examination they have asked you a question for 2 marks. Just after sharing with you another shape, I am going to share with you that question, how to solve. Even I will share with you how to solve that question. That's why you can understand, you have understood hopefully Korolynov's principle, and you can also understand how to solve problem based on this principle. This is the main motto of creating this video. I hope you are getting me right now. Okay, so let's go for that that last shape. So I am talking about in the last shape, that is, let's say it's a slab. Okay, what about slab? Length is there, breadth is there, and height is there. So for slab, volume by surface area ratio LBH to LBBH plus HL. This would be the ratio volume by surface area. So this is all about the concept of solidification time and based on Korolynov's principle. Okay, so now let's go for that problem which has been asked in GATE. I hope you are interested to learn that problem, right? So let's go for that problem and solve it. That would be quite easier and quite helpful for you. Now here is the problem. So what we have given in this problem, let me just share with you. In sand casting process, sphere and cylinder of equal volumes. So both the volumes are equal. Now what I have shared with you right now only, volume. If volumes are equal, so what is the formula for volume for the sphere? 4 by 3 pi r cube. What is the formula for volume for cylinder? Pi by 4 d square h. Okay, so we should write here volume of sphere 4 by 3 pi r cube. Volume of cylinder pi by 4 d square into h. These two formulas we require to solve the problem. That's why I have shared with you all formulas. Now next, separately cast from the sand molten metal under identical condition. The height and diameter of the cylinder are equal. So here the condition h is equal to d in case of cylinder only. Therefore this equation become pi by 4 dq. Okay. Now what we have to find out the ratio of the solidification time and sphere to that of the cylinder. That means we have to find out Ts by Tc. Solidification time of the sphere to the cylinder, then we have to find out Ts by Tc. Okay, now let's go for that. How to find out Ts by Tc? That is also important. Once you will come to know how to find out, then things become easier for you, right? So we have to first know the relation between sphere diameter as well as cylinder diameter. Once we'll come to know relation between sphere diameter and cylindrical diameter, then things become easier for us. Okay, then we can find out area and all that. That's right. Let's go for it now. So what we got basically here is that, so what we can write here, 4 pi d by 2 whole to the power cube, right? So pi by 3, 4 by 3 pi dq by 8. So this will become pi dq by 6. Pi dq by 6. So as in this question what state, equal volumes, that means pi by 4 dq is equal to pi by 6 dq. Now this d is for sphere, this d is for cylinder, that we have to denote. So we can write pi by 6 dsq is equal to pi by 4 dc cube. 5 pi get cancelled, 2 2 is the 4, 2 3 is the this one. So ds is equal to, dsq is equal to 3 by 2 dc cube, because I'm sending this 3 to that side. So because of the rule of the cross multiplication, we can write that. Now ds is equal to 3 by 2 dc cube, and we can write 3 by 2 dc cube. This is cube root, and because dc is cube, that means it will dc. So what we got here till now, ds is equal to, we need calculator, right? We need calculator. 3 by 2, this one we have to find out cube root. So 1.145, okay, this is, or 1.1447, because we have to take up to 4 decimals values. That's why we can get very good right answer, right? So ds equal to 1.1447 dc. We got the relation between diameter of the sphere and diameter of the cylinder. Now what we have to do, we have to find out, we have to do what? Ts by Tc. Now I have already shared with you the relation. What will happen in case of cylinder? If H is equal to D, then volume by surface area ratio is equal to D by 6. So in case of D by 6, dc by 6. Okay. Now in case of a sphere, D by 6, so ds by 6. Got it? How then? Now you can understand how the what I have shared with you in the earlier is useful right now. Probably you have landed in this on this page right now only, then probably we are seeing what is going on here. But if you watch the video from beginning, then you can understand what right now I am talking about. It's really important. It's really in-depth concept what I am sharing with you right now. Now what we got here, ds by 6, 6 by dc. 6 get cancelled. What we have right now, ds by dc. Now what is the value of ds? Okay, what is the value of ds? You can say okay. Now what we have to just write square, because we know that ts directly proportional to volume by surface area is whole square. So okay, so what we got here, ds by dc. Now ds, what is the value of ds? What is the value of ds? ds is equal to 1.1447 by dc and dc. So dc gets cancelled. From where we write this? So 1.147 square. What is the answer? 1.1447 whole square is equal to, how much we are getting here? 1.3103. Okay, it's ratio, that's why it is unitless. So answer is 1.31. A is the right answer. So this is how you can solve problem related to solidification time based on Korinoff principle. I hope you got some inside information about this topic and you have enjoyed the video. Thanks for watching. See you soon in my next video. Bye bye.